students especially. I'm sure the push to not show up was strong today. So really happy to see you. I just have a few announcements before I pass it off to Sarah, and then we'll introduce our speaker and get started. We have a pretty busy week at CSDE next week, and so I just want to let you students know we have an info session on the 23rd at 10 a.m. About applications for the Max Planck Population Health and Data Science School, I think is what it's called. But you've seen things go out, but we're there to answer questions about the application process, anything. So you'll see emails about that. And we have 2 workshops next week. One is a brown bag for our research data center. And one of our visiting scholars, Gio Rigi, will be talking about his work using longitudinal employer household dynamics data that's from Moocs. So that'll be pretty interesting. That is on the 24th at 12:30. And then we have an agent-based modeling in our workshop on Friday at 10.
Yeah, I'm really delighted Dan is here today, and I'm going to let Dan do the formal introduction. But for those of you who are students, one of the best parts of being a faculty member is watching the path of your various students. And Dan was in my research, was an NSF REU student, worked with me many years ago when I first started here at the University of Washington, and then I watched him go to Penn State, and then he went off and did a job, and he was in the field in Thailand for a long time. And I just kept seeing mentions of him on Facebook or Instagram, but we didn't really stay in touch. And then last spring, I was on a study section at NIH, and I was reading through an application, and I realized that the mentor of the student we were scoring the F-18 score was Dan. And I just was so impressed with his career and his mentoring of students and his amazing research that I thought we had to have him back. And I'm so glad that the Anthro department is here to support him and be his, because he was originally an anthropology major. So Ben, all yours.
Yeah, thanks very much. That's a nice thing that we have in common. So my name is Ben Marwick. I'm a professor of archaeology in the anthropology department here, and introducing Dan because he was the undergraduate student in the first class that I ever taught in my first quarter as a faculty member at UW. So very special moment, a real sort of full circle moment for me. So honors student, actually community college student in the Washington State Community College system, and came into UW as a transfer student and did anthropology honors with Professor Darrell Holman as his undergrad advisor, and they both co-authored a publication on that a few years after Dan graduated. Went on to Penn State to do his PhD there, and then a postdoc that took him to Thailand, where he sort of began his work in infectious disease epidemiology and demography, particularly in Southeast Asia. By coincidence, where I also work as an archaeologist doing archaeological exploration on Paleolithic archaeology in Thailand and Myanmar. So another nice sort of intersection of our past there. And then on to University of California, Irvine, where he's now an associate professor and runs his own group. So welcome back. So good, so great to have you to join us. And certainly been a great moment of me to reflect on what have I done with all those years since we first met in that class. And I will take just a tiny bit of credit for your tremendous success. Now share, of course, with Darrell as well. So thanks for joining us, and please welcome Dr. Clark.
Okay, so a lot to live up to, I guess. Can you hear me okay in the back? So sometimes I talk too fast and mumble. If I'm doing that, if you need a microphone, I'll do it. Just like raise a hand or something, or if I can just repeat myself, even better, because I hate like using microphones. So yeah, I'm going to present some work that my group is doing. We are looking at conflict in cholera, and in particular looking at night lights a bit. Not only night lights, but that's kind of the star of the show in this one today. And I've got several different analyses that I'm going to present here, so I thought best to give a bit of a talk outline to try to keep it all straight, and then I'll come full circle again at the end. So I'll start off with an impetus. Why study conflict in health? I'll move on to linking air raids in cholera in Yemen. So this is some work that my group has already done. We have a publication on this already. I'll move beyond that to looking at potentially looking at nightlights as a proxy for conflict. And then start asking some questions and using some case studies. So can nightlights be used to detect conflict events? And I've got case studies from both Yemen and Ukraine. Then asking, can nightlights tell us about populations and about population displacement? Again, using case studies from Yemen and Ukraine. And then we'll come back to this analysis that we already did, where we're linking air raids and cholera in Yemen, and say, can we swap out nighttime lights instead of the air raids data and get the same results? Well, night lights tell us about cholera on the ground, and some other elements of this as well, because we think there's more to it than just the air raid that's going on with the infectious disease spreading, of course. And then finally, I'll come back to implications and conclusions. I'll talk about some limitations of using night lights, some strengths of it as well, and what might be some public health utility of using this tool. So to start with, I'm going to use this quote from Paul Weiss. He says, most civilian casualties in war are not the result of direct exposure to bombs and bullets. They are due to the destruction of the essentials of daily living, so including food, water, shelter, healthcare, these sorts of things. This isn't a new concept, of course. Florence Nightingale, back in the 1850s, noticed that most of the British soldiers who were dying in the Crimean War were not dying from actual conflict events, but rather from preventable infections that they were getting. And I think importantly, she was using hospital records, using data visualizations. This is a coxcomb plot or a rose plot. You guys have seen this before. So she was really pushing data science way back then to point out that most of the people dying around this conflict are dying from stuff that we could prevent through sanitation, other preventive measures, and was able to put in some interventions and improve things to an extent. I'll push that just a little bit further too. So you all have probably, or if you think about this sort of thing, you've probably heard this quote before, that the first casualty of war is the truth. This one gets thrown around a lot. It gets attributed to lots of different people, so I don't even bother here. I think there's some Republican from California that gets some credit for this, but I think it's even earlier than that. And I would take it a step further and say, a part of that truth that you lose is knowing about the health of the people, knowing about the demography of the people as well. So you lose some data in these sorts of settings. And that means vital statistics are going uncollected. If they're even collected in the first place, then that gets disrupted. Disease surveillance systems fall apart. There may be populations in displacement, but you may not know where they are, what the magnitude of that is, anything else about the demography, and baseline health metrics are just absent or disappear, or really bad quality. Right? So there's a lot that goes missing. And these are all the things that you really need to have a good, strong public health system. You need data. And so this is kind of the impetus behind why we were focusing on why we look at conflict and health in the first place. So I'll move next to some work that we've already done looking at cholera and conflict in Yemen. And I don't know exactly the background of everybody. Probably most of you already know cholera, but in case you don't, this is a bacterial infection, at least a sudden acute watery diarrheal disease. Like it's a nasty disease. And normally transmission is occurring through contact with food and water that's been, with water especially, but food that's also been in contact with. So it's associated with poor sanitation, limited access to good clean water. That's cholera. And this paper, so this came out a couple of years ago. Maya Tarnas is one of my rockstar PhD students, and she's really driving this work. And what we did was we took data from the Yemen Data Project, a little link on the bottom left there, and they are recording numbers of air raids per unit of time per location. And then we've also got cholera case data, and this is from a combination that the WHO is putting this together. But this is a combination of data from the Ministry of Health and then also from areas that were not under control of the Ministry of Health. And at that time, a WHO group was linking these all together in an electronic data system. And in this map, what you can see, so this is kind of looking atemporally. So this is from 2016 through 2019. The yellow dots, they're bigger if there were more air raids in that location. And then underneath that, the red are the red polygons. The darker the color, the greater the burden of cholera in that location. And this is just thinking, not even thinking about temporally. So we've got some spatial overlaps here. And so our next step here is to try to look at the drivers, the patterns that are going on. What kind of helps to explain the numbers of cases in different locations and at different times. And to do that, we used a generalized additive model. And I'll explain these a little bit more later. But it's a type of regression that includes smooths, so spline functions as predictors. And we've got population density that we're accounting for, study week, so time. We've got an economic variable that's a principal component of, if I can remember this, it's petrol prices, food prices, and also the Yemeni currency devaluation. And then, actually, this is an error. And this one, we do not have recovery yet, but you will later. We've got a categorical variable for the conflict severity. So we've categorized this into low numbers of air raids, intermediate, medium, high. We've got precipitation, surface water, temperature, and NDVI, which is vegetation index. And then we've got a spatial smooth, so we're accounting for location over time. And the time and the location are important components here because we have repeated observations within administrative units over time. So there's a time series within each location. You want to account for the fact that you've got repeated observations over time. And we do that with the location spatial smooth, and we're also accounting for time study week. And so what I want you to look at most here, there's a lot going on in this model. I'm not even showing the spline functions here, but what we were most interested in is along the top. And you can see we built this model sequentially. So model A, we start off looking at, we're controlling for space and time and population density and the spline functions. But then we're looking at our first variable of interest. So that's the number of air raids. And the next one, we add in environmental factors that might also be important for cholera. And then in the third one, we've also got the principal component as well. So really focus on this here. And the main takeaway that we get from this is that more air raids, places that have more air raids have more cholera when compared to places that had no air raids. In fact, if you look at the highest numbers of air raids, it's about twice the incidence of cholera in those places in comparison to places 3 months back that didn't have air raids happening. That makes sense? Everybody following still? Yeah. We'll talk about GAMs a bit more here in a second, and the spline functions that go behind them as well. So that might bring up the question, how do air raids equal cholera? And so they're not dropping cholera from the sky, of course. That's not what's going on here. So what's the process that actually drives this? And so we spend a lot of time thinking about this. This is my students' diagram that they've drawn out. This is an example of a directed acyclic graph, a DAG. Anybody's familiar with that? Just some of the students have a little twitch when they see this. So I actually love DAGs. So we put together this DAG to start thinking about what are the processes, how do we get from air raids to cholera risk, right? And what we hypothesized is that the primary drivers here is it has something to do with infrastructure damage. And of course, infrastructure is kind of a fluffy term, but by this we mean like destroying roads, destroying water pipes, making it hard to get access to clean water and good clean food. And then also from displacement, which again, the population's moving somewhere else, they probably don't have access to good clean water, good clean food, and that sort of stuff. Right? And so both of these things we hypothesize lead to cholera risk, and we're showing this association as a positive association, not in that it's a positive thing, but that we believe more infrastructure damage, more displacement should lead to more cholera risk. And then there's one other important factor here that we were thinking about already at this time, but was not yet in this first model that we put together, and that's rebuilding does happen in some places. So all we had were data on numbers of airstrikes. We had no information on whether or not rebuilding was happening in places. But we hypothesized that rebuilding might actually then lead to a decrease in cholera risk in comparison to places that did not have a rebuilding process. And that's why I'm showing the negative, the minus sign by that. So it might be modifying what's going on here a little bit if there's some rebuilding going on. And we'll come back to that idea here in a little bit. So I think this already kind of brings up that there could be, or you could probably imagine already, there are some limitations to traditional conflict data. Right? They're valuable data, but of course they rely on reported events. There's all sorts of reasons why that can be difficult, right? So they're often incomplete or delayed, I think for obvious reasons. There's variation in the quality, coverage across areas. They focus specifically on violence and attacks, right? And I've already kind of alluded that we think there's more going on, like there's nothing about the rebuilding process in this sort of data. It can be subject to bias and political filtering, censorship. And again, I keep coming back to this. There's no direct insight into recovery. And we were hypothesizing already at this time that recovery probably has something important to do with this process. So this leads us to the question, what if we could track conflict and recovery without having to rely on reported events? So that really drives how we get into nighttime lights for this project. So there's a couple of different products out there. What we're using for nighttime lights is the VIIRS black marble data. I'll spend some time explaining it. So this is a visible infrared imaging radiometer suite. It's primarily on Suomi NPP satellites, some others as well. And the black marble part of it is it's the cleaned data that NASA has gone through and cleaned and calibrated. So they've done some work to remove problems with moonlight, clouds, stray lights, atmospheric conditions, snow, vegetation, stuff that can get in the way of getting a good clean shot of night lights. And these data are collected daily. They are cleaned daily, but there's some more clean products that are aggregated at longer time periods. And they come in at a spatial resolution of 450 meters, which, depending on what you're doing, is okay or not that great. If you're I do a lot of household level stuff, GPS points at a household or counting mosquitoes in a mosquito trap. 450 meters is huge if you're a mosquito. It's not tiny for a human, but for some things, especially if you're aggregating up at an administrative unit, it's pretty good actually. And so again, we've got this daily black marble product. It's been available since 2012, but there's also a monthly composite that's made from that daily product. It's cleaner, it's more stable, and that's what we're using for this work. And what I mean by more stable is you can imagine there's lots of places that have cloud cover for much of the year, for example. So Seattle has lots of cloud cover for much of the year. That makes it difficult to get a good clean shot every single day of the year. But if you go out to a month, probably get a good shot in a month. So this gives us something stable that we can do over time. I believe there's also a yearly aggregate, but we're not interested in that because then you can't really get interesting variations in disease cases or something unless you get a long yearly time series of data. And if you are really interested, we're getting these data from the Black Marble R product now as well. I've got over there. So this moves me into the first case study. I've got Yemen mapped on the left and Ukraine on the right. And the green shades there indicate the population counts, so estimated population counts in the governorates of Yemen and the oblasts of Ukraine. And you might ask yourself, why these countries? And they weren't randomly chosen. We purposefully chose these. There's protracted conflict in Yemen. There's recent escalation in Ukraine. You know, if we watch the news, it looks like everything started recently, but actually there were big events going on in 2014, and there have been lots of political violence going back even further than that. So focus on there's a recent escalation of events in Ukraine, a protracted conflict in Yemen. And there are different levels of pre-conflict infrastructure in these two places and also an international support. We think this makes these two places an interesting case study to compare and contrast. And for the first thing that we want to do, that first question is, can we detect conflict onset or an escalation onset using night lights? Right? And the way we're doing that is using a tool called BFAST. So I always think of breakfast when I see this. BFAST stands for Breaks for Additive Season and Trend. This is a time series approach that helps to detect major breaks in a time series data. So it decomposes the time series into trend, seasonal, and noise components, and then it helps you to detect whether or not there is a major break point, a shift. And that shift could be up or it could be down. It could be a drastic increase, a drastic decrease. And you want to detrend this because on a lot of time series, you'll see some seasonal variation or something. You want to know is that, like outside of that seasonal variation, did something really shoot up or really shoot down? And in this case, we're hypothesizing that the nighttime lights are going to go darker. So it's going to be a decrease from a conflict event. And so what I'm showing here are mean nighttime lights for Yemen on the left and Ukraine on the right. And the lines there that you can see behind that, those are coming from the BFAST tool. And you can see a pretty stark, this is across the whole country, right? So not even going into administrative units yet. You can see a pretty stark decrease, especially in Yemen, right? About the time that the recent conflict, or if there's a more recent one now, but at that time, the recent conflict has begun. And you can also see it in Ukraine right here. And there's a difference in magnitude as well. Okay? We've mapped these out as well. Real easy to see You can kind of see the red spots in there, I guess, maybe from the back. So these maps, the data are rasters, they're a picture, right? And they have pixels in them. And what we've done is we've taken the raster, the picture from before the onset of conflict, so like from over here and from after, and then we are dividing this post average by this average, and this is a ratio. And so if you're seeing a dark red, that's a place where it's much, much darker after the onset of the conflict. And if you see something that's like a bright blue color, that would be a place that is much lighter after the onset. Something that's yellow in between, that would mean little to no change in night lights over time. And so you can see like this area right here, not much change, maybe a little bit of growth. These areas here, a lot darker after the onset of conflict in these settings. Yeah, or no lights, really. Yeah, no lights. So the question was, what's going on with the black? And that's because the population centers are clustered anyway. So. Relatively clear. And then, of course, we don't want to just think about the whole country, like the BFest across the whole country. So you can, in fact, put this off and do this for every administrative unit. And what we're finding is that it works relatively well. It corresponds pretty well to reported what you see on the ground. Compare it to the Yemen Data Project. And there's similar projects in Ukraine that are counting a number of airstrikes and that sort of stuff. And it works pretty well for most places most of the time. And so what we take from this is that even without knowing the exact date of an attack, using nighttime lights, we could detect a change that's big enough to correspond with these conflict events. So we could use these to detect some kind of a big event that's happened. In this case, it happens to be conflict. Now, there's more to this as well. So I've already alluded to the recovery thing being a big part of our story, or we think it's a big part of the story. So you see these big decreases, but I think what you can also see is from Yemen, there's a bit of an increase after that in the night lights, but it's nowhere near the magnitude of what you see on the Ukraine side. It doesn't come back to the same level as much as it does in Ukraine. So there's widespread destruction going on, limited recovery in Yemen. In Ukraine, there's partial recovery. And if we go in and kind of zoom in on the different oblasts, it appears to be that there's more recovery, especially in non-Russian controlled areas. So this gives us some clues that light recovery does offer pretty good, it does work as a proxy for infrastructure restoration as well. The lights are starting to come back on, and they do so differently in different places. This goes back, of course, to our interesting DAG that says there's something important about infrastructure rebuilding. And I'll come back to that again. So next, our question was, can we know something about populations and maybe even about displacement using nighttime lights? And again, I'll go back to a generalized additive model. This time it's with a Gaussian distribution. Population is the outcome. The population count is the outcome. And we're estimating the population count per admin unit, per unit of time, using world pop data. And if we didn't have world pop data, there's like a couple of years at the end, we didn't yet have world pop data. So we used the World Bank pop growth formula to extrapolate that just a bit. And then our science question is, oh, it's not showing up. Huh. It's frozen on me. Our science question is, do nighttime lights, light recovery, and numbers of reported attacks correlate with estimated population counts? So that's what we're trying to do with this. So I've got, yeah, it seems to have frozen, and I think I've lost, oh, it's coming back on. I'm having Zoom problems, apparently. Sorry. Yes.
So in the map you showed, there were places where there was some big increase in lights.
Yes.
Is that where there's like internal migration of central areas, and then that? Okay. Okay. And then with that, we can imagine that one big as well.
Yes.
Reading together.
Yes, exactly. Yeah. And I can show, I'll zoom in and show you an example. Yeah, that's exactly what this is going on. Sometimes you can also have a situation where like
we're doing, like, if there's some oil activity or something, like, especially in coastal areas, like, if there's some kind of extraction or something going on, it might have to walk with, like, population as well. We think inland is more popular. You can use satellite, like, when you find the satellite and see population.
Probably, you need to stand with a speaker,
Oh.
even though you're not.
Yeah. Yeah.
Yeah.
So for the online people, we are, did it time me out? Is that what happened? Yes. So, yeah, let me, so for the people online, the question was, in the places where you're seeing, in the raster of the nighttime lights, in the places where you're seeing the lights go brighter, are those places where there's been a displacement, or is there a growing population there? And my answer was, that is the case. In at least some situations, there might be some other, like some business stuff going on in other places as well, but definitely in some cases, that's what we think it is.
And I was wondering, is there a delay in that measurement? I would imagine the first people go and live with lights that would have otherwise been on before, and then these are.
I think it depends. Yeah, I think it depends. I think it's a mix of both. Yeah, so sometimes people will go live with family members if they can, but sometimes a big group will move all at the same time as well. Yeah. Yes.
And us to incorporate the electrical grid and organization of the grid
Yes.
and how that might influence your.
Yeah, you could take out the whole grid and then everything would go dark.
Okay,
But I can imagine in Yemen that maybe a bit more localized, and whereas in Ukraine, it's more. Nationalized sort of distribution of nuclear power or going out or whatever.
Yes.
Because whether that would have
It
like a different signal.
It could. I don't know exactly what that would look like, but it could for sure. And I think we, so the question here was, does the electrical grid system influence this? And it must. I need to think about that some more. I would guess that it would be more distributed in Ukraine, as you suggested, and less so in Yemen. And I believe that we had talked to some folks that were talking about using diesel for like generators and things in some places as well. Yes. Yeah. And then another question here quickly was, would there be a lag in the displacement and the growth of a new displaced population? Would people move in with family members or other people first where there are already lights and then move to a new place for lights? And I think there's a mix of both actually. Okay, so I've got technology back. So again, the science question here was, can we use nighttime lights and the other things in the model to predict population counts? And what we're interested in is, do nighttime lights, NTL, does nighttime lights recovery and the numbers of reported attacks correlate with estimated population counts? And I highlight nighttime lights recovery here because this one's slightly different than what we've seen before. The way we measure this is we find that low point, a 2-month low point after the lights have gone dark, and then we compare each subsequent month to that point. So be this month divided by that lowest point. That's what we're talking about with recovery in this case. And more specifically, this GAN, this model has smooth spline functions per month for percentage of built environment in a location, for nighttime lights, the mean nighttime lights, and then nighttime light recovery, as I was just explaining it. The categorical variable is the attack severity. And this is the same as in the first model. So we've got it categorized for low, medium, high, and severe. And then we've got a spatial smooth again. So accounting for the location that we're focusing on. And these are the splines that come out of these two models. On the left is a model for Yemen, on the right is a model for Ukraine. And I'm going to spend just a little bit of time explaining what a spline function is, in case you're not used to looking at these, and sorry if you are. So probably everybody's used to running a generalized linear model. So like a logistic regression, a Gaussian, Poisson negative binomial. So you run your regression and you get a table that comes out of that. And maybe on the left-hand side, you've got your variables, your covariates, and then you'll have your coefficients. and then like standard errors and whatever kind of test and a p-value, right? So those coefficients, that tells you the effect size of that variable on the outcome, assuming there's an effect size there. With a GAM, you can do the exact same thing, or you can also use a spline function. And that spline function does not give you one number, one effect size. It gives you a different effect size for every value of that variable. So this one here that I'm showing that I've blown up, this is for nighttime lights. The x-axis is the values of nighttime lights. So on the far left, that would be very low nighttime lights. On the far right, that's the brightest nighttime lights. And the y-axis tells you the association and the effect size. This 0 point where the red line is, or the black flat line that you can see through there, if the spline and its confidence bands are fully below that, that means there's a negative association with the outcome for that respective value of the x. And if it's above that, that means it's a positive association. And so this is cool. I love GAMs. I love the spline functions because you can see nonlinear effects. You don't have to assume that it's a linear effect. You don't even have to play around with 15,000 different polynomial terms. And you can see a general trend, or if it's a curvilinear trend or more complex, right? And so this, it's not linear, but it's a positive association. Right? And so if we go back, again, on the left-hand side is Yemen, on the right-hand side is Ukraine. And what I've circled in the green there is that's the effect of nighttime lights on population counts, trying to predict population counts per unit of time per location. So positive associations, both Yemen and Ukraine. Not that surprising. Nighttime lights, like where people are, there'll be nighttime lights normally. And then interesting to us, the recovery variable for the negative association with both. So it seemed that places that had higher population counts had less recovery actually. So we found that interesting. And then I'll throw this on top. These are the results from the categorical aerial attacks. We keep them categorical here. We could have used them as a spline, but we did the first model as categorical, so we keep it the same throughout all of these. But basically what we see is, if you look at Yemen in the medium and high areas, there's a positive association. So more air raids were happening in places with higher populations until you get to this highest level here, and then we have no statistically significant effect there. We hypothesize that is because there are militant groups that are outside of population centers in Yemen that are being attacked sometimes, and you have really high numbers of air raids that are happening in those places that don't happen to be high population centers. Conversely, though, in Ukraine, it's not like that. In the high and the severe, you see an increasing level of attacks. And we know if you're following that conflict that most of the attacks in Ukraine are in fact targeting population centers. So, and this gets back to your question about populations and nighttime lights as well. So you can in fact zoom in. So on the top left, these are both examples from Yemen. So on the top left here, we've got Al Hazim. On the left, this is a satellite image from 2013 on the top left. And you can see it, I believe, in the middle one on January 20. You can see that there's a lot of population growth in the middle there. I don't know if you guys can make that out or not, kind of. Conversely, we can look at nighttime lights from the same location. So this is before and after conflict, and you can see that the lights are getting quite brighter there in that location. So this is a known displaced place where displaced populations are growing. And it's the same on the bottom as well. Same pattern, just a different location. And you might ask, why do the dates of the night lights not line up with the dates of the satellite images? That's an interesting question. And the reason is because you cannot get clean, clear satellite images of every place every month. But you can probably get night lights images of those places every month, at least in this sort of setting. If you go really high latitudes, or probably really far south latitudes, you may have problems. But this setting works pretty well for every month. So what have we learned from this? There's a strong correlation between population size and nighttime lights. Not surprising, we're not the first to show this. Heavily attacked areas are normally highly populated. So, some exception in Yemen, especially in Ukraine, but still in Yemen in the medium to high level as well. And recovery time seems lower in high population settings. So overall, we take this to mean that this is a pretty good proxy for population size, and we can detect some movement using it. Of course, there's some papers out there. Nita Barty has done some work on this a long time ago. Lots of other cool work out here doing the same thing, but a nice sanity check to do it in our location as well. Okay, so let's come back to that model that I showed you at first, where we were looking at air raids and cholera. And let's use that model. So that's a generalized additive model. It's a negative binomial. It's got counts of cholera cases as the outcome. And let's see what happens if we replace air raids with nighttime lights. And then I keep alluding to this recovery time possibly being important. We can include this as well as an effect modifier in this model. And so for those of you who want to see what's all in this, it's a GAM. It's got smooths for population density, for study week, so that's time. For economy, that's that principal component again. It's accounting for petrol costs, for food costs, and for devaluation of the currency. And then we've got an interaction for recovery, the amount of recovery, and the months since the minimum, how long it's been. Got the same conflict severity categorical variable. And then we've got some linear covariates for precipitation, surface water, temperature, vegetation index, and then again, accounting for latitude and longitude. So we've got spatial variables in there as well. And so if you look on the left here, this is the same model I showed you at the beginning. So for the high and severe, it's about twice the odds, or sorry, twice the risk of cholera cases, twice the incidence. For the most severe in comparison to places that were low, that had no air raids in the previous 3 months. This is the original model, but with that recovery interaction term. So we're accounting for recovery. You can see that it's the same general pattern, changes those coefficients a little bit, but same general pattern. And then, in this third one, that's simply replacing the air raids data with nighttime lights data. So it's inverse. What we're saying here is severe, that's the places with the least light, and the low, the places with the highest light. So simply replacing nighttime air raids data with nighttime lights. We don't get the exact same results, but pretty close. So curvilinear, still an association there. And then on the right-hand side, these are the other spline functions that I was telling you about. So on the top, that's week or month, actually. It's mislabeled. I should have fixed that one. You got population, the principal component for the economy, and then the location here. But what I'm really kind of excited about are these middle ones, these two. This is the interaction between the months since the onset of the conflict, and then on the y-axis, the amount of recovery. And this is a little bit more complex of a spline because it's an interaction. So the other one, you have one variable and it's two-dimensional. This time you got two variables and it's a three-dimensional interpretation. So it's like a contour map. These are your contour lines, right? And where it's dark red, that's where it's lower risk, and where it's really bright, that's where it's a higher risk. And what we find interesting is places that had nighttime lights recovery really fast had lower risk of cholera, and places that had very little recovery for a long period of time, or even places that had some recovery, but it took a very long time, like 40, 50 months, had much higher risk of cholera. It's not that surprising, but we thought it made sense, follows the DAG that we put together. So this tells us that nighttime light does work as a substitute for air raids, at least in this case. And we have this extra bit of information that we think is pretty valuable if you're wanting to think about what are the causal mechanisms that's going into this. It's not just air raids that equal cholera, it's probably about destruction of infrastructure and that sort of stuff, right? And we think that this is important. We hear talk about recovery, but mostly for symbolic reasons, like they get to rebuild so fast. And of course, this isn't happening so much in Yemen, or it does in some places, but you hear more about it in Ukraine in this case. But it's not just symbolic. It can modify disease risk, especially for a disease like cholera that's so important for having good access to water and sanitation and that sort of stuff. So there are some limitations here. There's geographic issues like cloud cover, forest canopy, high latitudes are problems. Ukraine had rolling blackouts, but arguably that's still a precursor to what's about to happen, and the lights come back afterwards or don't. And the resolution limits are an issue. I'm trying to speed up just a bit and run out of time. And I like to have, especially when I'm doing public health work, I like to have kind of a so what factor in here. So the so what here is these data are not that hard to access, and you can access them remotely and in a relatively timely manner. And so if you want data about what's going on the ground, pretty consistent and not that hard to access this. If you are someone who's targeting humanitarian work or public health work, you can do spatial targeting with this as well. And you can see recovery or the absence of recovery. And that might be something to really pay attention to as well. So having conflict-related data, we'd argue, super important for a variety of reasons. And nighttime lights are like a valuable complement to that. It doesn't replace conflict data though. The Yemen Data Project is awesome. People on the ground doing that work, that's amazing work. It doesn't replace that at all, but it does offer a valuable complement. And it adds some new dimensions, right? So we can see the destruction, but we could also see some recovery, and we can also measure some displacement from this. And so I'll close this with a kind of a final note on some of the hidden costs and full circle to why conflict in health. So as I was saying at the beginning of this, much of the suffering in war is not caused by the weapons themselves, but by the damage to health systems and infrastructure, sanitation, access to food, and these sorts of things. And that's not limited to soldiers. That impacts families, community members, other people that are living in this area as well. We see this in the news. We see attacks in Yemen. See people doing silly things with signal and joke about it, but they're bombing real people on the ground too, and destroying infrastructure in the process. And the disease outbreaks and the long-term health crises that as a result of this, they often aren't in the news. They go unseen, even though they can be major. Like this cholera outbreak that we're analyzing here in Yemen is enormous. It's an enormous cholera outbreak. And we would argue that it's important to document, to study, to vocalize these hidden things, to keep them out and to be loud about it so that people know that it's going on and so that things can be done about it. And we argue that remote sensing helps to bring this into view a bit. It's a valuable tool for that. And so with that, I need to thank one of my rockstar PhD students, Maya Tarnas. She's the one that's really driving this. This is her one of her PhD chapters. On the top right is Vladimir Menin, who some of you might recognize. He was at University of Washington for a while as well. So he's a good collaborator of mine. That's him making friends with an anteater somewhere around Oxford. If you don't know, at UCI, our mascot is an anteater, so we're kind of contractually obliged to make friends with anteaters everywhere we go. And then on the bottom is Tatiana Vasilyeva. She's a new faculty member in my department in public health, and she does some really awesome work on conflict and health with men who have sex with men and HIV in Ukraine as well. So if you're interested in that sort of stuff, look her up. She does really awesome stuff too. Some of this work is on GitHub. If you are interested in looking at script and data and that sort of stuff, I see someone looking for the QR code, so go for it. You could also email me. I get excited when someone actually uses it. And then this is my group at UC Irvine, and we do all sorts of cool stuff. Yeah, it's a fun group. So thank you. If you have any questions, I'll try to answer. Sorry, I'm a little moving.
No questions here.
Yes. So, yeah, okay. So the question was, how did we deal with blackouts? And basically, we did deal with them. We just treat the time series as if it's all the data that we have. So we know that there are rolling blackouts that were happening in Ukraine and still do happen sometimes. But if you think about what that would do to our data, it would mean that there would be a blackout that would either come right back if there wasn't an event, or if there was a major destructive event, then it would stay dark afterwards and you wouldn't see the bounce back. So we believe that it's caught up in the process, basically. Does that kind of answer it? Like it's happening in places that they're worried are going to be attacked. If it does wind up being an attack in that location, then you're going to see something with the recovery or not recovery that's related to that. Yeah, the recovery time is really important here, I think. And I didn't mention this, but the model where we replaced numbers of air raids with nighttime lights, you just like swapped it out. That model really only works if you have recovery in there as well. It doesn't work in the absence of that. You have to have that. That's an important factor there. Do you have a question as well?
I'm curious, what are the critiques of using lights? I mean, if I wanted to approach this in a critical way,
Yeah.
where would I poke at that?
Well, I guess you could put, I mean, be critical. Like, you mean like surveillance state types of critics or?
Well, I guess like, are some lights
Oh,
better photographed than others?
Yes.
Are you more
Yes.
likely to, like, how might the data not be an accurate reflection?
So we want to be, so the question for those of you online is, what are some critiques of it? If I phrase this right, are lights in all places equally comparable? Maybe is that
Just
yeah.
one possible way to say that, like, how are we hearing is, I just want to be able to think more critically about
Yes.
using lights.
Yeah, so the question is, how do we think more critically about using night lights? So there's lots of ways. I think approach it with some caution. And we analyze Yemen and Ukraine separately, partially for this reason, because you could see the seasonality in Ukraine is like very different looking than from Yemen. There's seasonality in both, but the troughs and peaks are way bigger, a little bit different. That's probably because they're at different latitudes, right? Very different location. Other things there's lots of things that can throw it off, like if you have like huge elevational changes, if you have snow, things like that. And you'd want to be careful about, like you wouldn't want to take a mean light from one area and apply it equally to another area. Like you need to train the data on that location. So you still need some, I'm a big proponent of having some ground truth. I don't think you can go just to the clouds and not ever get back on the ground. I think you can get a lot from it, but you need to be careful with it, especially comparing places, and even better if you have contacts on the grounds, if that helps. Yeah.
And I guess just to follow up on the other side of that, so one way to strengthen it, one thing that occurred to me was to look at cell phone data. Do you have access to that? And do you have any idea if they would mirror one another?
You mean like for movement patterns?
Yeah, or to understand like where the populations
Oh.
are.
Oh, so in these settings, I have not bothered to try for mobile phone data. That's an interesting question. Mobile phone data have its own problems too. So we've done some mobile phone data in work in Ethiopia, especially looking at population movement, and some other, like Caroline Bucky has done some amazing stuff with mobile phone data. Mobile phone data, what I would say is like mobile phone data are limited to the mobile phone towers, and they're not equally distributed across landscapes. But they're valuable for thinking about, especially like big population movements. Yeah, I would say there's no one tool that's like perfect for everything. For me, it's more about using a suite of tools and then trying to ground truth it a bit. So yeah, mobile phone data are cool too. Also not perfect. Yeah. Yes. Yeah. Yes. Hi. Thank you.
Given that the source of nighttime light data is NASA, are we worried?
Yes. I'm generally worried. We're not hearing a whole lot from NASA, but we know there are cuts happening, right? But I was talking to a geographer earlier, and we were talking about once upon a time, folks would pull the data themselves from the satellites, with big satellites, with satellite dishes, and then process them and then share those with NASA. It wouldn't surprise me if we go back to something like that at some point. The satellites are still up there.
Yeah. So there should be a workaround.
There could be a workaround. I don't know off the top of my head. Yeah. I don't know. And there's more than just this product. No, these ones are sports Starlings. Yeah, these are different than that. These have been around since for a while. But so usually a satellite will have lots of different sensors on it. And so this one in particular, I'm not sure what all else is on it and who actually owns it. Yeah, worried. NOAA data too. Oh my gosh. Anyways.
Also, the Europeans also.
Yeah, like Copernicus.
Europeans are just alike, this kind of data, NASA. So,
Yeah.
we can all.
So a lot of the other data here, well.
They also do weather modeling, now that it's. Just outsource that. Yeah.
Well, I'll source all our science too. So, yeah. Daryl, did you have a question? Okay. Yes.
I'm particularly interested in that finding about recovery being, I guess, was it less or slower in more populated areas?
Yes.
I'm curious of how recovery is measured, whether like the degree of infrastructure before, or sort of how far it has to fall when, an airstrike happens or something.
Yeah.
If that influences how much recovery needs to happen, or like how big that recovery value can get. Basically, is there influence just with the fact that an area might be more populated already in what that recovery value is looking like that might contribute to that inverse correlation, or is it?
I think they're related, actually. Okay, yeah. So the question was, let me see if I get this right. Is there something else going on with the amount of the population separate from the recovery that's driving that inverse association with recovery and the high population? I think yes. In my mind, what's happening is so the light levels in places with higher populations are higher on average and lower on average in places with no population, and there's some variation in where the attacks are happening. So in Yemen, the highest level wasn't necessarily where the highest populations were, but in Ukraine it was. But it's not all populations all at the same time, right? So I think all of these things come together and kind of make for that inverse relationship. Yeah. So I don't completely know, but that's what I think is happening. Yeah. Yeah.
One, I heard concerns. And two, I know you talked about the years.
Yeah.
I saw that the eastern regions have more response.
Yes.
I was curious if you see in like, oh, you used to work about those specific regions. Like this region, which is about a lot of news articles, journalism about that. I don't know if you kind of like teach them.
So I know Maya has done some of this work, especially she follows all things Yemen, and then I kind of pushed her into doing a comparison with Ukraine in this one. And yes and no. So we've done some of the collaborators are Ukrainian, and so they kind of say yes, like that's key. There's attacks going on there and that sort of stuff. But we haven't done like a thorough scientific like trying to find records like news records to correspond with it. But it would be totally doable, I think. And the Yemen Data Project must be doing part of this too, I bet. There's some, is it like ACLA? There's several groups in Ukraine that do this as well. So I bet they're actually incorporating that when they're collecting the attacks data. There's several different groups doing this in Ukraine. So I bet they are actually incorporating some of that in their data collection process. Yes. So,
I think Sala conflict database has.
yes. Yes, like everything, like they kind of aggregate everything. I forgot to repeat this question. So the first one was so somebody really likes Comic Sans, and then the other question was are we incorporating news data into this as well? And I said that we kind of anecdotally looked at some of the spots, but haven't done that in a widespread manner at all. But noted that, and someone else here noted as well, that some of the data repositories are in fact incorporating those data in the tax data. Yes.
Thank you. I had a third question about Saturday resolution.
Mhm.
You said it's 450 meters. Is that,
Yes.
like 450 square meters or is it 450 long?
Yeah. So a pixel would be 450 meters or 450 meters, roughly. It can change a little bit depending on where you are on the Earth. It's like 15 seconds on latitude, but basically it's about 450 meters on the side and on the other side. So if you had it in like QGIS or ArcGIS, you could zoom in on the pixel and literally measure the side of it. It should be roughly 450 meters. Yeah. Mm-hmm. Yes. So the question was, have we incorporated religion into this with regard to like lights or like thinking about like Ramadan and things like that. We included actually early on. So the question was, have we considered including anything about like religious practices or something like that into our analyses? And early on, actually, we tried to, so like Ramadan's a big thing, right? And can affect night lights for sure. And we tried to include that, we did include a variable that indicated Ramadan or not Ramadan in the Cholera model early on, but it didn't tell us anything like it. Didn't add any predictive power to the model. It wasn't significant. And so it ended up, just for parsimony, we ended up not having it in there. For Ukraine, I wouldn't even know where to start. I know, I don't know it as well, but I know that there's some different areas. I wouldn't know how to start actually, basically. So for Yemen, a little bit, and for Ukraine, no, we have not. You had a question, yes.
Data resolution.
Yeah.
Do you have any like obstacles or challenges with processing that data?
This wasn't bad. So the question was, with the data resolution, did we have any problems with processing the data? 450 meters is actually pretty clunky. So that's pretty good, actually. And Yemen and Ukraine are relatively big, but not enormous. Like, so if I'm trying to pull data like 30-meter resolution for all of, I don't know, Ethiopia or something like that, that's a big problem. You can't get one single shot of the whole country at any point in time anyways. It's going to be like 4 different panels and you have to stitch them together and hope they line up. And, so this really was not that bad. And the Black Marble R package really works nicely for this. There's also, if you're interested in this sort of stuff, Google Earth Engine has really grown in leaps and bounds in the last year for accessing most types of remote sensing data, like free remote sensing data. And it's not that hard. Like the JavaScript or Python that you need to use to pull it down, it's not that challenging. It's worthwhile too. Like there's so many data sources on there. Like we've all moved into Google Earth Engine at this point. It's so much available there. Yeah.
So I want to just reiterate, this is a fantastic talk. I think like remote sensing and infectious disease demography, like my favorite things. So that's topic.
You're a little biased.
Yeah, absolutely. And then one thing that I find so impressive, and I guess I want advice, is I see the Parker group or the Parker Labs.
Yeah.
What advice do you have for people who want to collaborate or create like a lab around specific topics, or any advice or experience with like collaborating with your students?
Oh, so we're all kind of introverted, but we're also super friendly. So like if anybody wants to collaborate, they should just email us and start up a conversation. But if you're talking about building a group, I build pirate ships. I don't know if that makes sense. I kind of collect people who, like, we're all very different from each other, but we all know that we're kind of different. And we just kind of get along that way. And it's like, I've just kind of always done it in different things. Like, so it's about team building, like figuring out who's the right person. Like I think about it when I'm recruiting a new student, like, so maybe the student's a rock star, but they're not going to get along with everybody else in the lab. So maybe I should hold off or not, or think about getting them into another group or something like that. I try to think about it. There is some chaos and randomness too, because you can't always predict how people will or won't get along. But I like to build pirate ships, and that, I mean, it's not like we're not all wearing uniforms and doing the same thing. We all have our own passions and go in different ways, but we kind of come together and get stuff done together when we have shared interests and common goals and that sort of stuff. And for us, it's mostly been about things like spatial epidemiology or medical geography, issues around justice and humanitarian health and public health, or vector-borne infectious diseases. But not everybody does the same thing. We all do maps and GIS. But everybody's doing different projects with it. Team meetings, we try to do weekly. I'm on sabbatical this year, so more like monthly this year. But coming together for teams, so everybody gets to see each other and what each other is doing. That gets us all excited. But it's I don't know, it's a dance. It's like a pirate ship, though.
Thank you, Dan.
Thank you for having me. Yeah. Thank you. Yeah.
I have a.
I brought a book. Checked out a book from CSDE 2008. And I brought it back. I'll give it to you. Just sitting on my stack of books right here. $15.